Okay, let's continue the lesson. Yesterday's lesson, you have learned about what is oxidation, what is reduction, what kind of reaction is considered oxidation. So let's just go through back. Any reaction where there is a gain of oxygen or a loss of electron, loss of hydrogen, or you see increase in oxidation number, it's considered oxidation. Whereas for reduction will be anything that lost the oxygen, gain the hydrogen, gain electron, or if there's a decrease in oxidation number, you call it as reduction. Then you learn what is redox reaction. So redox reaction will be a reaction where oxidation and reduction happen simultaneously, happen at the same time. Okay, then after that you learn about oxidizing agent, reducing agent. Agent means must do a work. So oxidizing agent means must do oxidize someone else. Reducing agent means must reduce someone else. So then you learn the examples. Okay, then I gave you yesterday an assignment where you find the oxidation number. So I hope you can already understand a little bit. Now today we go through which one of these are considered redox reaction, because sometimes they ask you in objective question which of these are redox reaction or redox reaction, whichever way you pronounce. Okay, so now for all this example, I want you to think about the oxidation number, which is oxidizing, which is reducing, which is oxidation agent, and which is reducing agent. Okay, first example, MgO2 MgO. Is this a redox reaction or not? How do I know redox reaction or not? I must know whether is there oxidation and reduction. Okay, so first I see, very simple, Mg become MgO. That means the magnesium has gained the oxygen. So obviously magnesium has go through oxidation. What about oxygen? So you don't know. You have to check on the oxidation state. So the best way to know whether something is oxidized or reduced, the best way is you don't see whether got oxygen or not, whether got hydrogen or not. Just quickly write down all the oxidation number. Oxidation number means the charge. You just write down all the charge. So for example, magnesium is the pure element. So yesterday you learned pure element means the charge is 0. So this one, the charge is 0. Element, molecule, oxygen molecule, charge is 0. Magnesium, positive 2. Oxygen, negative 2. Okay. Now if you notice, magnesium from 0 become plus 2, meaning there's an increase in oxidation number. This has gone through oxidized. The magnesium has oxidized into magnesium oxide. If it's oxidized, that means this is known as the opposite, which is reducing agent. Because what's the function of a reducing agent? It will reduce something else, but itself get oxidized. So it's the opposite. If you notice, it's the opposite. Okay, now the oxygen, from 0 charge, it decreases to negative 2. So since there's a decrease, it's a reduce. The oxygen has reduced. So that means this is the oxidizing agent. Because oxidizing agent means it oxidizes someone else, but itself being reduced. Okay, now there is oxidation, there's reduction. So obviously this is a redox reaction or redox reaction. This is a redox reaction. Can understand? So the best way you want to know equation is a redox reaction or not, just check on the oxidation number. These are called oxidation number. Just check the number of charge. This is the simplest way. Alright, okay, let's go through the second equation. Tell me what's the oxidation states. Tell me which one is being oxidized, which one is being reduced, which is oxidizing agent, which is reducing agent. So how do I do everything? Always start first with oxidation number, because that is much more simpler. Okay, so if you notice, zinc is pure element, the charge is 0. H is positive 1 because the hydrogen is bonded with non-metal, so it will take positive 1. Whereas chlorine will be negative 1. Zinc is positive 2 here. Chlorine here will be negative 2. because got you got what you can there is a 2 atom of chlorine, so it's -2, and then your hydrogen molecule is 0. Okay, so you tell me now which of this reactant, which of the reactant is oxidized. You always go back to the reactant. Don't care much about the product. When you compare it with the reactant. So now zinc from 0 charge increases to +2, meaning zinc has been oxidized, meaning this is my reducing agent. Whereas if you notice here, hydrogen from +1 decreases to 0. +1 decreases to 0, and can you see here, -1 decreases to -2. So meaning this one has gone through reduction. It has been reduced. So this is your oxidizing agent. Always remember, reducing agent and oxidizing agent is for the reactants. You don't go and accidentally say the product. You go back to the reactant. Okay? Okay, so if you notice, the oxidation reduction takes place at the same time. This is called as a redox reaction. Okay? Okay. Next example. Is this a redox reaction or not? How do we know whether it's a redox reaction or not? I have to find all the oxidation states. So we find one by one. Now, for this one, we usually carbon, we don't know what is the oxidation number, but hydrogen we know, and carbon is a non-metal. So when hydrogen bonded with non-metal, this one will take +1 charge, but since got 4 hydrogen, it's +4. Okay, whereas your carbon will take -4, because the entire thing is 0 charge, right? Okay, your oxygen molecule, it's a 0 charge. Your carbon here will take what charge? What charge will it take? It will take -4, whereas here will take -4 as well. Why? Because oxygen here is -2, right? So -2 times 2 atom, I get -4. Obviously this one will be +4. This one will be +4. Now your hydrogen here is +2. This is -2. Oxygen, we know it has a charge of -2. Hydrogen is +1, but because got 2 atoms, so it's +2. Now we go one by one. We just check if this entire methane is oxidized or reduced. If you notice here, from -4, there's an increase here in the oxidation number. Okay, so this one has been oxidized. And moreover, can you see the carbon actually gain the oxygen and loses the hydrogen? Can see carbon gain the oxygen and it loses the hydrogen. So obviously this one has been oxidized, and this one now is reducing agent. That is the reducing agent. Okay, then look at oxygen. Oxygen from 0 charge, it decreases to, over here got -4, there's also -2 here, so it decreased, there's a decrease. So this has been reduced. So this is your oxidizing agent. Oxidation and reduction happen at the same time, so this is a redox reaction. Okay, can? Okay, next example. Is this excuse me, is this a redox reaction or not? We check. So we check first with oxidation number. Now aluminium is a pure element, so the oxidation number is 0. Copper will be +2. Chloride is -2. Why -2? Supposed to be chloride -1, but because got 2 atom, it's -2. Over here, aluminium plus 3, chloride is negative 3. Why negative 3? Because got 3 atom, right? And here copper is a pure element, charge 0. Okay. Don't look at this word single displacement reaction, all no need to see. Just look at the equation. Now, if you notice, aluminium from 0 increases to positive 3. So meaning the aluminium has been oxidized. If it is oxidized, meaning this is the reducing agent, is the opposite function. Okay. Whereas copper chloride, and look at copper chloride, from positive 2, there is a decrease in the oxidation number. From negative 2, there's a decrease in oxidation number. So meaning this has been reduced, meaning this is the oxidation agent. Because oxidation agent means I oxidize the aluminium but myself is reduced. Okay, that's why it's exactly the opposite. Okay, so oxidation and reduction happen at the same time. This is a redox reaction. Now, if you notice here, in this equation, what can you see? If you notice, the aluminium actually displaces the chlorine, right? Aluminium displaces the chlorine. You have learned this in your salt, the chapter salt 8. Chapter 8. You have learned this in your chapter 8. Can you see aluminium displaces chlorine? Displaces copper, because aluminium is more reactive than copper, so it displaces the copper and then it forms aluminium chloride solution and copper. So this is a single displacement because only one time only displaced, right? So every kind of single displacement reaction is a redox reaction. Okay? Okay? Okay, next. MgO plus H2O gives you MgOH. Now, if you notice, right, this is a compound, this is a compound, this is a compound. Now, if everything is a compound, that means there is no mixture of element and compound. If everything is compound, usually it's not a redox reaction. Usually it's not a redox reaction. Like for example, you look here, this is a compound. But here got, this is a compound, but here got an element. This is a molecule. So there's a mixture here. But over here, if you notice, actually water is considered a compound, right? So all these are compound. If everything is a compound, usually it's not a redox reaction. So if you still want to confirm, we go through all the oxidation state, okay? Magnesium here, the charge is positive 2, oxygen negative 2. Hydrogen here is positive 1, but times 2 become positive 2. Oxygen is negative 2. Magnesium here is positive 2. Your oxygen here is what? Negative 2, but there is a 2 here, right? So times, you become negative 4. And then your hydrogen here is positive 1, right? Positive 1 times 2, positive 2. Okay? Okay. Now we check one by one. If you notice the magnesium here, from positive 2, does it still remain positive 2? Yes, it still remain positive 2. So no changes. Now your oxygen, here got negative 2. But can you see here also got an oxygen? Here also got another oxygen. So total there is negative 4 oxygen charges, negative 4. Here also negative 4 oxygen. So no changes. Now your hydrogen, here only positive 2. Only one hydrogen, right? So positive 2. Here your hydrogen is also positive 2 charge. So there is no changes. There is no changes in oxidation state of all the elements here. No changes. There is no changes. No transfer of electron. No transfer of electrons. So therefore this is not a redox reaction. So can I conclude now? If there is all compounds, okay, there is no mixtures, there's no element, no compound, there's no mixtures, everything is a compound, usually it's not a redox reaction. Okay, now one last example before I conclude the lesson. Is this a redox reaction or not? Now if I notice this is an element, a molecule, a compound, so there's a mixture, so usually it's a redox reaction. But let's just check. Oxidation number of a pure element is 0. This is a pure molecule, 0. This is positive 2, negative 1 times 2, negative 2. Zinc from 0 become plus 2, so it's oxidized, meaning this is my reducing agent. 0 become negative 2, so there's a decrease, this is reduced. My chlorine is reduced. My chlorine is the oxidizing agent. Oxidation and reduction happen at the same time. This is a redox reaction. Okay, so just to recall back, today you learned from the equation given, you need to identify whether it's a redox reaction or not. How do I identify? First thing is, you just write your oxidation state for each and every single element and ions. You write them, then you compare them. Okay, and always remember, if that reactant goes through oxidation, meaning the reactant is a reducing agent. If the reactant goes through a reduction, meaning it's an oxidizing agent. It's exactly opposite. Okay, now there's a list of questions that I'm going to give you in your assignment, so I want you to just see if this is a redox reaction or not. All right, the next subtopics I continue in the following lesson.